All right, so we've laid the foundation. We've talked about what .NET is and what Visual Basic is. Now let's start looking at the specifics of the Visual Basic language. And we'll start out by looking at variables. Let's go back into Visual Basic Express and create a new project. Again, we'll create a console application. And we'll create a variable. So a variable is an identifier which is associated with a value, and that value is of a specific type. So to create a variable, you use the dim keyword, and then you pass in the identifier. So let's just use name. Then you're going to say what data type it is. So in this case, we're going to create a text variable. So we're going to use a data type called string. And then we can assign that value right here at the declaration time. So I can put in a literal value like Rob as the value associated with the identifier name. Now I can also do this on 2 lines. So I can say here dim name2 as string. And then on another line, actually set the value. Right? So initializing the value is optional at declaration time. You might, have to go do some calculation or whatever, get some user input to decide what the value is going to be. So the declaration of the variable, which is this line, and then the setting of the value, this line, can be separate. And of course, once you've set the value, you can change it. So I could say here, name2 is now equal to Scott. Right, so now we've changed the value associated with the identifier. Now let's focus a little more on types. So here we've seen the string type. This holds some text. Now let's take a look at whole number types. So let's create a variable that's going to store a whole number. So we'll say here dim x as, and we have a few choices. The first one is short. And that's going to be, say, equal to 10. Actually, we can even go smaller. We can go byte. And that's equal to 10. So byte is the smallest whole number type variable, an 8-bit unsigned integer, meaning it can only hold positive values. The next one up we use fairly commonly is short. This is a 16-bit number. We can find the maximum and minimum values by taking a look at the documentation, or each of the number types has a max and min value, which will tell you what the maximum and minimum value are. So for a short, we have 32,000 and change up to minus 32,000 and change up to positive 32,000 and change. Okay, so that's a 16-bit number. And then the next one, which is probably the most commonly used whole value data type, is the integer. And you can see that that's a 32-bit signed integer. So in this case, the range of values goes from minus about 2 billion up to positive about 2 billion. Okay. And then if you do need numbers larger or smaller than that, you can go to long. This is a 64-bit. So we can see here the min value. Whoops. Let's try that again. There we go. Min value, right? Quite large, or quite small in this case, sorry. And then max value is quite large. Now, as you need to store larger or smaller numbers, the storage required in memory is going to grow. So, the byte was 8 bits, the short was 16, integer 32 bits, and long 64 bits. So when you're storing whole values, again, the most commonly used type is integer. Okay, so what about floating point values? So just like we have different types to represent different sizes of numbers, we do have the same thing with floating point numbers. So the single is the 16-bit version. So that's going to store a number that potentially can have a decimal component. And then we have double is the next one. And this is, again, is probably the most commonly used for just storing floating point numbers in general. And then the most precise, but also requiring the largest storage, is decimal. Decimal is very commonly used when you're doing financial calculations. So if you need to store currency values, decimal is quite often the one that's used by developers. So even though it requires the largest amount of storage, it does have the greatest precision, and you want to have very precise calculations when you're working with dollar and cent values. There are a couple of other data types which are sort of unique to themselves. One of these is Boolean, and it can hold two literal values. There's true or false. Okay, so the Boolean is about logical values. So you can use the actual literal values, true or false, or you can use an expression. So I could say here, dim age as integer, say, is equal to 25. Then we could create a Boolean variable, say, call it of age, as Boolean is equal to age greater than or equal to 21. Right? So this is an expression which will be evaluated, and the results of this expression will be assigned to the variable. Right? In this case, the age is 25. 25 is greater or equal to 21, so the value of age will be true. And then one last data type we want to take a look at is the date data type. And to set literals, there's a kind of a legacy syntax where you use the pound signs, and then it's month, day, year. So say 5/13/1964. Whoops, not 1064, 1964. So that would set the date, May 13th, 1964, into the variable age here. Now, in the examples I've shown, I've always indicated what the data type is going to be for the variable. But we can actually use a feature called type inference, where Visual Basic can determine the data type for us by the value we assign to it. So I can say here dim x is equal to 10, and if you notice when I hover over x, it knows, oh, this value is an integer. So basically what it does is it infers the data type from the value I assign. Now this will only work if I assign the value at the same point where I declare the variable. I can't say dim x and then later on say x is equal to 10 and use this feature. It just doesn't work. So if I say here dim x is equal to Rob, you'll see it picks up that that's a string. And if I say x is equal to 3.14, then it picks up that that would be a double. If I can get the IntelliSense to pop up. Let me just move on to the next line and see if there we go. And I can say dim x is equal to false, and that should pick that that's a Boolean. Okay, so basically, again, what's happening is that Visual Basic is determining the data type of the variable by the value that's assigned to it. One last thing to note around variables, and that's naming convention. The convention for variables is that they are camel-cased, meaning that the first letter of the first word is lowercase, and the first letter of each following word is uppercase. So, for example, name is equal to Rob. I would use, again, lowercase n. If I wanted first name, then it would be first and then capital N for the name. Say, for example, I wanted 3 words, so last, invoice, date. Whoops. Again, the first letter is lowercase, but the first letter of each other word is uppercase. If you have an acronym, then a 2-letter acronym, how about XM for XM radio? 2-letter acronym, both of the letters would be uppercase. But if it's 3 or more letters, then the first letter is uppercase, and then the other values or the other letters are lowercase. So if I wanted to say XML value, I would type it like that. The last thing to talk about in this section is not really about variables. It's more about the Visual Basic language, and that's statements and expressions. So each line of code I've created is called a statement. So if I say here dim x as integer is equal to 5, that's a statement. dim y as integer is equal to 10. That's another statement. And then say dim z is equal to 15. That's another statement. So basically, the end of the line indicates the end of a statement. Now, we might have a line that's a little bit longer. So let's say here, dim a is equal to x plus y plus z. What I can do for long lines, and this isn't really a long line, long lines would normally span off over here somewhere, is I can put them on two lines by using the underscore character. So the underscore or the line continuation character indicates that this is considered to be one single statement, even though it spans two lines. There needs to be a space preceding the underscore character. So I couldn't say equals underscore. I have to put equals space underscore here for that to work properly. But that is considered to be one statement. And as I mentioned previously, this is an expression that gets evaluated. So it's the value with the operator, and we'll talk more about operators in a bit. And then another value, that's an expression. So that gets evaluated. And then the value of the result of that expression gets evaluated with the plus z. And then the result of those things gets stored in the variable that we're using the a identifier for. So each of these, again, is a statement. A statement can be put on multiple lines by ending each line with the underscore character. And then when we have values separated by an operator, that is called an expression. All right, so let's review. We talked about variables. Variables are an identifier that's associated with a value, and that value is of a specific type. We use the dim keyword to create a variable, and we can optionally assign an initial value to the variable at declaration time. We saw that Visual Basic can infer the data types for us as long as we do provide an initial value for the variable at declaration time. Here is a chart showing a subset of the data types we talked about. Integer and long being two of the whole number data types. Boolean being the logical data type. Single, double, and decimal being floating point number data types. Date being the date data type. And then finally string being the text data type. Now what we didn't talk about is this column over here. So when I talked about the data type names, I was talking about the Visual Basic data type names. But for each of those, there's an associated framework class library data type name. And this comes back to the whole language independence. So while each language may have their aliases for the data type names, they all map into data types that are part of the framework class libraries. So what in Visual Basic we call an integer, in C# is called an int, but both of those really map to the int32 data type that's part of the framework class libraries. So if we choose to, we could use the framework class library data type names instead of the Visual Basic data type names, although that's not a common practice. But it is important that you understand that there are different data type names that are in the framework class libraries because there are a couple places inside of the .NET framework that you do need to know that. And we'll touch on at least one of those later on in the course. And finally, we talked about statements and expressions. So as I said, each line of code is a statement. A line of code ends at the end of the line. If you have long lines of code, you can separate them onto multiple lines using the underscore or line continuation character.